Alright, so today we're supposed to go over some NumPy and Matplotlib stuff. We've done some of those things already previously. Maybe after having done the homework we might have more questions about some of the things. A couple people that I've worked with, they seem to have tried to go ahead and do for loops and if statements, sort of a C++ style, rather than trying to do some of the fancier NumPy stuff like we did in MATLAB, which is fine. So I don't know. I definitely want to go over some plotting things, definitely to do an example of a 3D plotting with mesh grids and that sort of thing, because there is a problem like that on the homework. What other stuff besides going over some more plotting stuff, because we haven't done very much plotting? What else would you like to see me help you with in terms of NumPy? Anybody have any suggestions? I'm going to ask questions for on the test. I'm going to ask things that are similar to homework problems. And it's fine to write for loops and do all that sort of stuff, for the test instead of using the NumPy where or the logical index, that sort of thing. It'd just take you longer possibly, but there's no reason why you have to do that. Yeah, Rusty. We will do 3D plotting. That's definitely in Python, and that is something I want to cover today for sure. Is we're going to do an example of a surface plot, a basic surface plot type thing like we did in MATLAB. Yes. So logical indexing. Also, I do think it's probably a good idea to go through the where, do the where again. But yes, that's a good idea. We'll do some more logical indexing and stuff like that too. Okay. So why don't I start off doing something just with the plotting, just make sure we get the plotting out of the way, because that's the one thing I need to make sure we cover. So we can do something, just a simple plot. Let me first import NumPy as NP, and I'll import matplotlib.pyplot as. I'm starting to change my mind of whether I want to keep doing plot or PLT, because everybody writes PLT. I don't know how long I can be a conscientious objector on that one. I don't know. I like it better than PLT, but everybody does PLT. Anyway, so first I'll take X and I'll create it to be a Linspace. Okay, and Linspace works just the way you're used to it. The first is the starting value. The second is the ending value. So I'll make this go up to 2 pi. You'll recall that pi is not an automatic constant in Python, but it is a constant in NumPy. And then here you put how many points I want. Say I want 300 points. Okay, and you know what? I'm just going to go ahead and save this. Okay, and I'll just go ahead and run that. And so Linspace is not defined. What did I do wrong? Linspace is not a normal Python command. It is in NumPy. It's a NumPy command. So now I run that. Now I look at my variable explorer. Okay. Now, this variable explorer is a little bit, it's correct, but it's a little confusing because it's telling you that X is of the type float64, which all the individual values in X are actually that data type, okay? But the data type of X itself is a NumPy array. Okay, Linspace returns a NumPy array. So if I print what is the type of X, okay, versus what is the type of the first element of X, those two things will be different. Okay, X itself is an ND array, a NumPy n-dimensional array. And the type of the first element of X is the float64. So be careful. The spider, it says here, it says array, under the value of x, it says array of all these things in there. But technically, the type of x itself is a NumPy array. Okay, so that's a little, I'm not quite sure I like the way that Spider does that. Okay, that's the data type of the elements inside x, not the data type of x itself. Okay, so you'll notice here that Linspace returns a NumPy array. Okay, if it had been a list, remember lists don't have all of the operators, don't work for the list, so it returns an array and not a list. Okay. So then I could say now y is equal to NumPy sine of x. And then y will now be an array. I'll run that one. You see y is now an array of a bunch of different values. Okay? And I can do plot x values, y values. Okay? Now, you'll notice here that my window, I have it pop up in a separate window. I personally like this better than having it in the command line. I'll show you. Thank you to Jake, it was you who told me how to do this, right? If you go under File, was it File? Tools. Tools, Preferences, and then Editor, IPython Console. IPython Console, Graphics, and the graphics backend is it's by default in inline. That's why it ends up in all of the output. I like to have it as automatic, mostly because when I did my homework problem with the robot arm moving, that I was able to get it update in the figure and see the animation, and I was not able to make it do that the way I wanted to inline. So it doesn't really matter. You can leave it in inline. I personally prefer to have it in another window. That's this guy right here. Okay, and so here we've got got the plot of the sine. Just like in MATLAB, you can change the color here. I can say I want it to be a magenta line, and I want it to be a dotted line instead. I run that. And it gave me an error because there's no comma. There.
I typed what you typed and I got an attribute error. Modulo Matplotlib has no attribute plot.
Do you have plot.plot?
Yes.
And do you have the import matplotlib pyplot as plot?
Yes. Oh, I didn't put .pyplot.
Okay. All right. Now, notice one thing, and this is curious. I just realized this the other day. You might not have noticed it at first, but actually the original blue line and the original red and the red line, magenta line that I just plotted are both there. Okay? And in the I guess it must have been in office hours. But you'll notice if you use the hold on that I talked about using the hold on last time, right? You will see you often get a warning that says that hold on is going to be deprecated, okay, in the next version. So actually that hold on is going to disappear in the next version of Matplotlib, and you won't be able to hold on and hold off like you do in MATLAB, okay? Now, at first you're like, well then what am I going to do? And as it turns out, Matplotlib made a change here from the way MATLAB does things, and actually is a better change. It's cleaner and easier. And what you'll notice is that by default in Matplotlib, if you plot something in the same figure, it automatically plots together with what was ever there, which is the opposite from MATLAB. If you plot something new, it automatically clears it and puts the new stuff there. Matplotlib is not that way. The quote-unquote hold on is already automatic in Matplotlib. And if you want to plot over, delete something and plot again, you need to clear the figure. Okay? So in Matplotlib, if you want hold on, just leave it the way it is. If you don't want hold on, you just clear your figure before you plot something. Okay, so then you don't have to worry about holding on, holding off. You either, it's automatically held. If you don't want it held, you just clear before you plot. Okay, so if we wanted to clear before we plotted, we could do this. We could do plot.figure1, and to make sure that we're plotting in the figure number we want, and then we could clear that figure. And now you'll see when I run my code here, you'll see that that figure is going to change. You watch that figure when I hit play here. You know, now it goes away, the blue stuff goes away, and actually the magenta stuff that was there goes away, and now I just plot the magenta stuff. Okay. X label and Y label, I think it's just that simple. Just do X label, X in radians. I think that works, right? So you get X in radians, then you can do plot.Y label, Y equals sine X. And there you got your Y label. Okay? So again, many of the things that work in MATLAB work here. I did also put a new link on D2L to the Matplotlib PyPlot list of all of the functions that are in that. So you can look on D2L and just explore a little bit. I'm not really asking you to do anything crazy, but just some pretty basic plotting stuff. Okay. The not a numbers do work as well in PyPlot, and actually this is a good place where we can do some logical indexing. Let's say we want to get rid of everything where y is greater than 0.75. Maybe we just don't want to plot that stuff. So maybe we can set all of the y's that are greater than 0.75 to be not a numbers. Yes, before we go on, Sahin.
Is the idle not do plot because I don't have spider right?
Idle does do plot. What you will need to do in your idle is to do plot.show at the end. If you put plot.show, that will make sure that this figure shows up. Now in Spider, apparently you don't need that, but in idle, or if you run your command from the command line, if you just run it in Python from the command line, you'll need the plot.show. So try that and it should show up. Did it? That should work for you if you do plot.show.
Yeah.
Okay. It's not necessary in Spider, but it doesn't hurt if you put it there. Okay. Okay. So let's say we wanted to take all of the stuff where the y was greater than 0.75 and get rid of it. Okay. We could write a for loop to loop through all of the y's and check each y individually and set it individually to not a number, you know, in a for loop. Okay? Or we could use logical indexing. Okay? Let me do print y greater than 0.75. Okay? And what that is going to give for me is it's going to display an array, a NumPy array whose values in the NumPy array are Booleans. And it has only displayed the first three and the last three, and those are all false. The first three values here are not greater than 75. The last three are greater than 75. But if we did something like this, well, anyway, here, let's do this. Let's change this to not be 300, but change it to only be 10. Now we can see all 10 of the values there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's all 10 of the values, okay? The first two are false. That one and that one are less than 75. Then that one and that one are both greater than 0.75, and then all the rest are under. So when I do y greater than 0.75, that gives me a NumPy array filled with Booleans telling me where, in which index positions that is true. So what we would like to do is set all of the values in y where y is greater than 0.75. We want to set them to not a numbers. But if first, as an intermediate step here, we index y with this Boolean array, that's logical indexing. So that this thing here, y, where y is greater than 0.75, will return the y values that are in the 0, 1, 2, and 3rd. The 2 and 3 index position, it will return those y's. And those y's should be greater than 0.75. It'll print them on the screen. That one is indeed greater than 0.75, as is that one. And we can see that's this point right here is the 0.9848. This point here is the 0.88866. Okay? Now, if we take those values and set them to be not a numbers. Now, I don't know, there may be a better way to do this, but this is the way I have seen, and it should work, where you need to take the string not a number and convert it into a float. Let's see, I'm curious if I do print on what that will be. But I've seen this work where if you take the string not a number and convert it to a float, that will be a number that's not a number. And now if we look in our plot, we don't have those 2 points, just like it does in MATLAB. Okay? So here's a situation where we used logical indexing. Okay? We used logical indexing to get where the y's that are greater than 0.75. It's a Boolean array filled with Booleans, and then I'm now setting all of the y's where that Boolean is true to be not in numbers, and we're getting those 2 points not being drawn. Yes?
Can you still like use one to index another array?
You can still use numerical indexing, I think is your question. You can use numerical indexing or logical indexing. Is that your question?
Like, I think in MATLAB we did maybe x and then did the y greater than equal.
Yes, so you could do this as well. Is that what you're saying, Xavier?
Mm-hmm.
Okay, so this will set not only the y values where y is bad to not a number, but it'll also set the x values where y is bad to not a number. Now that's not necessary. We'll get the same plot. We get the same plot because if either x or y values are not a number, it won't plot them. But yes, I mean, you can, when you can index any array, whether it's x or y, with any Boolean array. So you have lots of flexibility there that you can use y to change x, you can use something else entirely, to change x, whatever you want. Okay? Then we can increase this back to 300 and we'll see a better looking plot. Here's our better looking plot. Everything above 0.75 is gone. Okay? And if we wanted to, we could change our y lim to be we can change our y lim to be from -1 to 1 so that we see the scaling, that it goes from -1 to 1. Excellent. The y lim and x lim commands are just like they work in MATLAB essentially. Okay? All right. Now, as a example, let's solve this in a different way. Let's use logical indexing, but using the where command. Okay, now this is going to be longer and more convoluted than solving it the way we just did. This is the best way, but I want to show you how to work the where command. Okay, just in case you might want to use it. Okay, so what I'm going to do now is I'm going to set a variable called ind, which stands for indices, and I'm going to set that to numpy where y is greater than 0.75. Now the where command works similarly to the find command in MATLAB, and basically what you do is you pass to it an array of Booleans. Okay, and you know what? I'm going to change this back down to 10. Okay, it's going to give you an array of Boolean. You have to pass to it an array of Booleans, and it will return to you the index positions where there's trues in that Boolean array. Okay, so let me run this, and you know what? Let me go ahead and print out ind here. Okay, so ind, I'm going to print another thing too. I'm going to print y greater than 0.75 as well. So print out both things. Okay, so here is y greater than 0.75. It's the 0, 1, second, and third indices where it's true. Okay, so the where command returns for me the index numbers where it's true. Okay, now let's try this. I'm not sure if this is going to work or not. Let me try it and see. I think it will, but we get lucky. It did. It worked. It did just the way we wanted to. Okay? So it worked, which is nice. So basically it got rid of those two. Now, what's the difference here? This is different because technically we used numerical indexing here. Okay? Ind is the numbers 2 and 3. It's not an array of booleans. Okay? So we've used numerical indexing because I passed to it a 2 and a 3, and it made the index 2 and index 3 equal to not a number here. Okay? So it was numerical indexing. Now, what's lucky is that this all worked out great. Okay? But what's interesting is that what is the data type of int? Okay, so I'm going to go ahead and I'm going to do what is the type of int? Okay, and I need another parenthesis. The type of int is actually a tuple. You know what? Let me print int again. So the type of int is a tuple. And you can see that it's a tuple because there's parentheses at the beginning and end. You know, parentheses indicate a tuple. Okay? Now, what's interesting is that this tuple contains one thing. There's this one thing in that tuple, and then there's a comma and nothing else after it. So it's a tuple with only one thing in it. And I can emphasize that by saying, print for me the length of int. How many things are there in int? There's one. It's a tuple with a single thing in it. And what is that single thing? It happens to be a NumPy array. So let me change the order here. I'm going to print int. What is int itself? Then what is the type of int? And what is the length of int? Then what I'm going to do is say, well, what is the type of the first element of int, index 0. What is the type of that? Okay, and I'm also going to write what is the length of the first element, the 0th position of int. Okay, so here is int. It is actually a tuple. There is one thing in that tuple, this thing right here, and then the comma and nothing else. What is the data type of the 0th element of int? It's a NumPy array. And what is the length of that NumPy array? It has two things in it. Okay? So if I want to get, for example, this number 2, I might want to take the first one and then get the second, do something, find where the first one is and do something with that, and then find where the second one is and do something with that. Okay? I haven't even gotten there. I have not yet been able to pull out where is the 2. Okay? So now what I'm going to do is I'm going to say print the length, print the data type of a double index here. So this thing here says return for me the element number 0 of the tuple int, which itself is a NumPy array. And then the result of that, I want to now return the 0th element in that thing. So this indexes the tuple, and this indexes the array that's inside of the tuple. Okay? And then if I print the length of int 0, 0. Okay? So let me run this. It didn't work. Okay, interesting. So I get an error. So let's look at what's happening here. Okay, this is int itself. It is a tuple because there's parentheses. You can see it, the data type is a tuple. There's one thing in it. Okay, what is the data type of that one thing? It's a NumPy array. It has a length of 2. There are 2 things. There's the 2 and the 3 in it. Okay, then what is the data type of the 0th element in that NumPy array? And that is a 64-bit integer. That's the number 2. That thing is 2. And then I've asked what is the length of that thing, and I get an error. Okay? The type NumPy ints, the 64-bit integer, doesn't have a length. It's an integer. There's one thing. Okay? So apparently asking how long an integer is gives you an error, because an integer is just an integer. It's not a list or an array or anything, so it's bad to ask if it has a length. Okay? Now MATLAB wouldn't do that. If you asked for the length of a scalar in MATLAB, it would tell you 1. Okay? But in Python, an integer is a different data type than a list, and an integer can't have multiple values, so there's no reason to ask for its length. Okay, so if I just printed ind00, that would give me the number 2, and if I printed ind01, that would print for me the number 3. Okay, that's the ind00, that's the ind01. Okay, and this happens all the time, and I'm pretty sure, didn't I talk about this last time, about why this thing is a tuple? And that's because if I was going to do a where on a matrix, I know I talked about this to somebody, but I'm not sure if it was office hours or in class. Was it in class?
Yeah.
Okay. So the reason that thing's a tuple is because I could index a matrix, and a matrix would give row, comma, column. And so that's why that's why it makes sense for it to be a tuple. But like I say, this happens all the time in Python, that it's returning for me things of data types that I'm not expecting, and I have to do this sort of analysis to figure out what's going on. Now luckily, in this case, it didn't matter one bit. I could send this weird tuple that's containing arrays of stuff to be numerically indexed, and it worked okay. Okay, so in this case it didn't matter. In the homework, if you're trying to use the where command, you're not going to index something like we're doing here, and you actually have to pull out which is the one, which is the number in there. I need to know the number in there, not not a tuple or an array. And so you need to do this sort of indexing here to get the number. Okay? All right. So now we did a little bit more emphasis on that where command, a little bit more on logical indexing. Jake, is that what you wanted to see for logical indexing? Sort of just reviewing that? Okay. All right. Let's look at a 3D plot. Okay. And you know what? I should probably add in here plot.figure1 and plot.clf to make sure we get rid of whatever was already there. Okay. What the heck? Oh, I did figure 3. Haha. And don't worry, I'm going to go through all the lines in this code to explain everything to you. Let me make sure. Okay, so basically we have this nice 3D surface plot. Okay, kind of like what we would, want to see from MATLAB. Okay, now how did I do this? Okay, first of all, I need to import pyplot because I'm going to use the figure command and the CLF command. So I need to have the pyplot in there. Okay, I'm going to use mesh grids and Linspaces, which use NumPy, so I need to have NumPy. Okay, and if I want to do three-dimensional plots, I also need this part of Matplotlib called Axis 3D, and it's one of those things where I never remember this, and I always have to go back and copy and paste. But you need this from mpl_toolkits.mplot3d import axis 3d. You need to make sure this is case sensitive, that's a capital A and that's a D. And essentially, it's importing stuff having to do with 3D axes into into your program. Now, what's really curious is that Spider is telling me that I've never used that. But if I take that out, it won't work. I don't know, maybe because I've never done something that's like Axis 3D period. Spider thinks I'm not using it, but I actually am because of some of the things that I'm doing in here. Okay, yes?
What's the difference between using from?
Right.
Maybe this
Okay, so what's the difference between import and from? So what from does is it will take only a certain part of a module. So Matplotlib is enormous, okay? And actually, PyPlot is only one part of Matplotlib, okay? And so this Axis 3D is another part of import, and I'm saying basically from this module, I only want to import this thing. Now, I'm not sure, but I'm pretty sure that I could maybe rewrite this thing to use from and import, and then it would and then PyPlot would have its original name. So there, I'm not exactly clear because I'm not a super expert on all of it. But basically, the from is saying I only want to take out some part of it. I only want to take out the thing that's called Axis 3D. Okay.
Could you show me the end of the mesh grid line, please?
Yes. Okay. So that's a good question, Sean. Let me look a little bit more. At this point, I'm a monkey typing in stuff where I know if I want to do 3D stuff, I need that line of code, but I'm not exactly sure. I should do some more homework on that, and I'll get back to you. Okay. So if you want to do 3D stuff, you're going to have that line in there. Okay. Now, what I'm going to do first here actually has nothing to do with 3D plots. This is all NumPy stuff. Okay, I'm going to use the NumPy mesh grid command, and the mesh grid command works exactly the same way as you're used to it in MATLAB. You send to it two things. You send to it an array of x values, and you send it an array of y values, and it will return to you a matrix of x and y things where you overlap them over top and you get all of the combinations of x, y points. Right? You guys remember that? Or have you suppressed that memory? Okay? You know, we've done a lot of mesh grids, okay? And it works exactly the same way, okay? Now, technically this is technically needs to be a NumPy array, and x and y are also technically NumPy arrays. They're two-dimensional NumPy arrays. And I can emphasize that by putting a print type x, and maybe I'll do print x dot shape. You know what? I'll do two things. I'll do print len of x, and I'll do print x dot shape. So when I run this, okay, we see the type of x is a NumPy ND array. Okay. Now, if I just do length of x, it only tells me 300, okay? Which I'm not sure, but I'm pretty certain that's just telling me the size of the first dimension of x. Now, usually if you're working with NumPy arrays, you're not likely to use the len command. The len command is actually a basic Python command that is intended to be used on lists or tuples. Okay, so len is really for tuples and for lists, not for NumPy arrays. You can see it does work, and I'm pretty sure what it gives you is the first dimension of it. Okay, what is more commonly used is shape. Now, anybody want to guess? Someone who doesn't know. Okay, so if you already know how shape works, don't answer. But someone who doesn't know, when I've typed x dot shape, what do you think is happening with the syntax here? What am I doing? What is shape? Anybody want to guess?
Is it a member function of the class?
Okay, there's a good guess. She says it's a member function of the array class, because I'm putting an instance of an array x period and then a name. Okay, so she's saying maybe that's a function, a member function. or what's called a method in Python. Okay? And that's a good guess, but it's actually not right. Okay? If it was a function, I would have to send to it parameters. There would have to be parentheses after that to be a function. Even if it didn't take any parameters, it would have to be open, close parentheses to say I'm not passing anything. It's actually a data member. Okay? It's a data member. So shape is a data member, and well, what is the type of that data member? Okay. Oh, I didn't type tag. What is the type of that data member? It is a tuple. Okay? So shape is a tuple, and what that tuple is and it's actually a good idea to be a tuple, because what that tuple is the size of x. Okay? In each dimension. Okay? And you can see when I printed it, when I printed x.shape, there's parentheses around it. That indicates it's tuple because there's parentheses. There's 300 rows and there's 300 columns. So if I changed this to a 4, we could see that change. We can see there's 400 rows and 300 columns because rows are y value things. There's 400 y values. There's 300 x values. 400 rows, 300 columns. Okay? Now, like I said, this data member is actually a good thing to be a tuple, because what's the difference between a tuple and a list? Can't change a tuple. Since this is a data member, I should be able to change it. Like I mean, couldn't I say like x.shape? Let's make the 0th element of x.shape equal to 600. Okay, now that says I can't change the tuple. I'm not allowed to change that there's 600 rows. Well, I haven't changed the data in X, so why should I be able to change how many rows it has? So that's actually kind of good that it's a tuple. But I wonder, I wonder if it'll let me forcibly change that. Say, well, I don't want it to be 300 by 400 by 300. I want it to be 200 by 200. Haha. Well, that says I can't reshape that. So that's interesting. I wonder, could I change that into 1201? No, it won't let me do that either. No, it shouldn't. It needs to be, what's 300 times 400? 12,000? 100? How many zeros? 4 zeros? 4 zeros. Will it let me do that? No, it tried. I don't know, that's interesting. So I never tried this before, but if you try to change the shape of its shape data member, apparently it tries to reshape, move the data around somehow. I've never tried that before, but basically, if you're mucking around with the shape of the matrix, you don't want to do that because that's going to change the way the values are. So that's kind of curious. Apparently, if I chose the right things, I don't know, can I make it be 300 by 400? I wonder if it'll let me do that. No, it wouldn't let me do that either. So I don't know. Maybe there's some way that it will let you change that shape. But basically, shape is there for information. That you change X into whatever you want, and then you ask it, hey, what is the shape? Or it's a way to know how many rows and how many columns there are. Okay? And so that shape is a data member of the NumPy array class. So it's kind of interesting. And if you go and look, there's other data members of the array class. There's also methods as well. There's a method for getting the transpose of it. There's a method for finding inverses. There's all sorts of interesting functions, methods or member functions to the NumPy array. Okay, so we now see that X has 400 rows, 300 columns. Y also is the same way. It has 400 rows and 300 columns. Okay, and the Linspace, well, we've done Linspace before, right? It works exactly the same way what we just did. Start value, end value, how many values you want. Okay, so this line is basically exactly the same as the way you do it in MATLAB. You just have to put the MPs in front of there because it's NumPy. Okay, so then this line here is going to use NumPy's sign command. Okay. And I'm going to pass to it x times y. Now this is also a very important difference from MATLAB. Okay? In MATLAB, if you have a matrix times a matrix, it will do matrix multiplication. Okay? And we can tell that it's not doing matrix multiplication here because you can't multiply a 400 by 300 matrix by a 400 by 300 matrix. You can't do matrix multiplication on those two things. Okay? But it's not doing matrix multiplication because the data types of x and y are NumPy arrays. And NumPy arrays, by default, the multiplication symbol for with NumPy arrays is element-wise multiplication. That's a difference from MATLAB. Okay, if you have a NumPy array, it's element-wise multiplication. If I wanted a actual matrix multiplication, I'd need to use NumPy dot command, the dot, DOT. Okay, and that is how you can do matrix multiplication. Now, I'm not sure, I don't think I've ever asked you to do anything matrix multiplication in this class. We've been avoiding doing matrix multiplication by putting dot times in MATLAB. Okay, so that's okay actually. If you're using NumPy arrays, you're already doing the things that you want to do, and that's going to be element-wise multiplication. Okay, now if you had the NumPy matrix data type, okay, if you use multiplication on the NumPy matrix data types, that is matrix multiplication because it's a matrix. And a matrix data type is different from an array data type. Okay, for what you have done so far, you're only interested in the NumPy arrays because they do element-wise stuff. Even if it's organized like a matrix. I mean, X looks like a matrix, right? It's got 400 rows and 300 columns. It looks like a matrix, but its data type is technically a NumPy array, okay? Now, I could convert it into a NumPy matrix if I wanted to, but then I'd have to worry about matrix multiplication and all that sort of stuff, okay? Yes?
How do you do element-wise multiplication with matrices?
Right. How do you, and I don't remember, but I'm pretty sure I did it in the primer. Did I do that in the primer? Can't remember. Let's see. You can tell it's been a long time since I did. Here we go. That's matrix multiplication. Did I ever do element-wise? Did I? With a matrix?
Oh, sorry.
See, that's an array. Those are that's element-wise, but those are arrays. Then dot xmat times xmat, that's matrix. But I haven't done element-wise with a matrix in here. Did you see that? I don't see where I'm doing element-wise in a matrix. This right here is matrix multiplication. The first time I did matrix multiplication, it didn't work because the shapes were incompatible. And then I sliced out the parts of a matrix that were compatible and did matrix multiplication. I'll have to check on that. Good question. Oh, I did not mean to click on that. I'll have to check on that, Sean. Was that you that asked or Xavier? Xavier, good question. One way for sure you can do it is if you have a matrix, you can use the NumPy array command to convert the matrix into an array and then do multiplication and then convert it back to a matrix with the matrix command. That would work, but there's got to be an easier way. I'll look into it. Yes, Preston.
I want to move the mesh grid graph plot, like the actual what it looks like.
How do you rotate it?
Yeah. Did you already show that?
Yeah, I have not shown that. You click here, and
Can you do that if you're not?
if it's not in the interactive mode, no. If your graph is inline, you can't do it. You need to have it in interactive mode. So you'll have to go to the preferences like we did under Preferences, Tools, Preferences, IPython console, Graphics, and change that to automatic. Because if it's in line, then you won't be able to rotate it. Okay. All right. So I got 2 minutes and we haven't done any of the 3D stuff yet, but it's really not that big a deal. So this gives me my z with element-wise multiplication because x and y are NumPy arrays. Okay? Then I'm going to open up the figure 1. Now, what I'm going to do here is I'm going to have that return something. Okay? And so what fig is basically a reference to that figure. And I can do different things with it. Okay? And one of the things I can do with it is I can access this member function. So fig, I'm not even sure. Let's see, what is the data type of fig? So its data type is a Matplotlib figure. Okay? So there's a class for Matplotlib figures, and they have data members and member functions. And one of the member functions is get current axis. And I'm saying I want this axis to have a 3D projection. Okay? And so I'm telling this I want a 3D projection. And remember, this projection equals, presumably projection is not the first argument in the list for the GCA function. It must be argument number 3 or 4 or whatever. And I want to use all of the default ones except for projection. I want projection not to be its default value, but I want it to be 3D. Okay, so remember when we talked about functions, we did that. And so now AX, if we do its data type, I know I'm out of time. Let me do type AX, and I do it. It's going to be an axis class. Okay, and then the axis class has a member function that I can do a surface plot, and it's just like surf. Pass it a mesh grid defined by 2 matrices, pass it the matrix that has all the z values, and then I'll go ahead and get my plot. Okay? And if you're in idle, you need the plot show. If you're in Spider, I don't think you need it. I don't think you need it when you're in Spider. Okay? So it's that plot surface that is just, that's like the surf command. Okay? And again, I'm not a super expert in it. I just know I need to do this. I need to open my figure, get my fig, then I need to get the axis out of the figure, and then I need to use axis's data member function to plot the surface. Okay? All right. So